Hi class, today we're going to be continuing section 4.3 on logarithmic functions. And this is part 2. Okay, so first we're going to start with something called the common logarithm. And this is the logarithm with base 10 and is denoted by omitting the base. And so this looks like just log of x. So this actually is log base 10 of x. So this is a helpful note is on your calculators, the log button uses this log 10. So that's what part of the reason this is so common. That's why it's called the common logarithm, is your calculators are made for it. And then there's also some good applications for base 10. So we're going to look at an application. So scientists model human responses to stimuli using logarithmic functions. And specifically, psychologist Gustav Fechner he formulated a law dealing with how humans respond to stimuli. And this is the formula here. So it's S equals K log of I over I naught. And this is where S is subjective intensity of stimulus. In other words, it's like the feeling of what's happening. So for example, like by the time you feel like sound has gotten twice as loud, it's actually gotten like a good chunk louder using the logarithmic function. Okay, and then I is the physical intensity and so that kind of means like it's the actual like length of the wave function that sound is doing, because sound moves in waves. It might be like the length of a cycle or something like that. And then I naught is the threshold intensity All right, and this is usually like it's the base level for when we first start to recognize it. So it might be like the quietest something is when you first are able to hear it. And K, this is a constant that depends on the type of stimulus. Okay, and now we're going to use an example using this common logarithms. Yes, sorry. So, example. So the perception of loudness, which we're going to denote B, or decibels, in decibels, sorry, not or. dB. Okay, so the perception of loudness of a sound with physical intensity I, and so it's given by the following formula. So B equals 10 log I over I naught. Okay, and then where I naught is the physical intensity of barely audible sound. So we're going to find the decibels or the loudness of a sound whose physical intensity is 100 times that of our I naught. Okay, so this means that I equals 100 times I naught. So if we're looking at our formula, B equals 10 log of I over I naught, which is 10 log of 100 I naught over I naught. And so now we're going to cancel the I naughts. And we'll get 10 log 100. And now since we have 2 zeros here, and log is secretly base 10, that means we're going to have 10 times 2, which just equals 20. So the loudness of the sound is 20 decibels. So now we're going to move on to something called natural logarithms. So the most convenient, I think that's how you spell convenient, choice for the base of logarithms for the purpose of calculus, which a lot of you will move on to, is the number e. I know this might seem like a strange choice, but like we showed in a previous section, e can actually be very useful. And so the logarithm with base e is called the natural logarithm and is denoted ln. So it'll look like ln of x. This is log base e of x. That also means that ln of x is the inverse of e to the x. And I might occasionally write natural log instead of log and have to go back. I'm a little more used to writing that, so don't be, oh, I just erased way more than I meant to. Erased a line, okay. Okay, natural log. So don't be surprised if I accidentally write natural log and have to go back and erase it. I use natural log more in some of my own grad classes. All right. So now we're going to look at the properties of natural logs. And these should seem very familiar. So the first one is the natural log of 1 is 0, since e to the 0 equals 1. The natural log of e equals 1, since e to the 1 equals e. The natural log of e to the x is x, since they are inverses. And similarly, e to the natural log of x equals x is also because they are inverses. And on calculators, there should be a little ln button. And it's probably by your E button. And I know my own calculator, there's just one button that says log, and I have to go through there to get all of these, including the natural log and E. So you can either like Google how to find something on your calculator, or you can just use Google as your calculator for your homework, for some of these log problems when it calls for it. All right, so now we're going to look at an example. So we're going to find the domain of logarithmic functions. So we're going to find the domain of the natural log of 4 minus x squared. So since the domain of the natural log of just like the natural log of x, the regular one, is 0 to infinity, that means that we need 4 minus x squared to be strictly greater than 0. This implies. So now we're going to look at what values of x will be greater, will fall in this category. So I'm going to define something y'all should have seen in 116, but I'm going to kind of talk through it as we do it just in case. So we're going to have the set of x such that x squared is less than 4. Right, and I'm going to kind of denote what every part of this means. So the curly bracket, that means it's a set of, and it's a set of this, so set of x. This means such that, and it's such that this condition holds. So that's kind of when you read something like this, either in a textbook or online, it's curly bracket, something, line, and sometimes the line is a colon. I like to use lines. So set of something such that this condition holds. So we're looking at the set of x such that x squared is less than 4. So now we're able to do some work within this set. So this is the set of x such that the absolute value of x is less than 2. And how we got here is we took the square root of both sides. And then since we're working with an equality, that means we need to have an absolute value on the x. And so then this equals the set of x such that it is greater than -2, but less than +2. Because that's how the absolute value function works. And so that just gives us the interval -2 to 2. And they are soft brackets because we just have a strict inequality. There's no less than or equal to sign. So therefore, the domain is -2 to 2. So we can take x's in this interval and plug them into our initial equation up here, natural log 4 minus x squared. And those values will give us outputs that are like real. They won't give us an error or anything like that. So that is how you find the domain of some of these functions. All right, thanks class.